and welcome to Coffee and Open Source, a place that we can talk about open source things, have fun, and learn about really, really awesome people in the community. Today, my guest is Ian Taylor. Say hello, Ian.
Hi everybody.
Awesome. Well, thank you again so much for being on the show today.
Thanks for
And
having me.
yeah, and one of the things that I want to be completely clear is that Ian was kind of elected to do this. I asked some folks on the Go team if there was anybody that would be interested, and everybody's like, "Talk to Ian. He's got tons of open source experience." So I hope that this conversation uh, hits a lot of people really well. So Ian, do you just want to maybe just give a brief intro about who you are and what you're currently doing?
Sure. Yes, my name is Ian Taylor, or Ian Lance Taylor on the internet. I work on the Go team at Google. I'm a Google employee. I have been a Google employee for maybe 14 years now, and I work on Go. I work on the language itself. I work on compilers. I work on the standard library. I do a lot of, just a lot of general stuff around the language and the language ecosystem.
Awesome. So there's a saying that I've always heard in like the open source community. It's like we all stand on the shoulders of giants, right? Like we work on the things that other people have worked very, very hard to put together. And working on the languages team, I'd imagine it's like one of those things where there's not a lot of there's not a lot of amplification of the people that work on languages, right? Like obviously the people who invented the languages are quote unquote famous, as you would say, but the people that are working on a day to day, like they get to do the things they love without really being bothered, right? Do you see is that something that you've experienced?
Yeah, I'd say that's pretty much accurate. I'd
Yeah,
say. I don't know how famous language designers really are. I mean, they're famous in a small group of people,
sure.
but
I mean, like in the tech space, right? Like,
yeah,
you can name like there's only been like six languages that like have been created that like people actually like use. Not six is probably a low number, but like you could easily say like, oh, I know who created Go, or I know who created C++, or Java, and all these other like large languages, right?
true.
But yeah, like they can easily like walk through Walmart and nobody would know who they are. Uh, uh, Excellent. So, do you want to talk just a little bit? I imagine that you've been in the open source field or in the open source space for a long time. Do you want to talk about how you got started?
Sure. I was thinking about that before when we talked about doing this interview. I started working on open source before the word existed because when I started on it, it was called free software. And of course, a lot of people still call it free software. Even I still call it free software often. Um, my first encounter with free software was actually I grew up in Cambridge, Massachusetts, as it happens, and back then at least, anybody could walk through the Harvard Science Center, which I used to do walking my way to high school, and there were one time I saw signs, which I guess Richard Stallman had put up, or some friend of his, saying, "I'm going to start this GNU project. I'm going to create a free software alternative to Unix." And at the time, nobody really had the free software wasn't something people talked about. Not free as a concept. Of course, most software back then was handed around, but there wasn't kind of the philosophical attachment to it. So I saw those posters. And that was my first encounter with it. But I was still young. I didn't start anything then. Um, it wasn't until later, maybe around 1989 or so, that I graduated from college at that point, and someone showed me the GNU compiler GCC, and it was free software, of course. And so it was this great compiler even back then. And I was always interested in compilers and languages. And so I started playing around with it. I was working for a company at the time which worked on this really obscure computing platform called Alpha Micro, um, which they ran their own operating system. This was the kind of thing people used to do back then. It wasn't Unix, it wasn't anything. It's called Amos. And I ported GCC to support Amos. And, that's kind of how I got into the free software field. And I've been working in it pretty consistently ever since then for a number of different companies.
Yeah, and you currently work at Google, correct?
I currently work at Google. Been
Yeah,
at Google for maybe 14 years now.
yeah. No, it's so I'm going to date myself, but I'm a bit younger than a lot of other people that got started in the open source space. So my open source, the first like HTML was the thing that kind of first I came across as like something that was real open source, right? Like JavaScript, HTML, CSS, like you can build anything with that,
Right.
right? and the specs were very well known and all of that sort of jazz. But like when I was in college, I'd have professors that worked on the FreeBSD project and they worked on all sorts of other stuff, and they'd always tell these stories, and I was just always look at them like, how did you survive with basically having to build all of these pillars from scratch, right? So when you first got started, you talked about Richard Stallman, you talked about the GNU project, like, so what was the feeling in that space? I don't know if you got into computing basically right out of high school, right out of college, or if you got into it a little bit later, but um, like generally, like what was the atmosphere like in those times around the
Yeah,
concept of open source or free software?
well, that's an interesting question. I'm not even sure I know exactly how to answer that. I mean, I started computing when I was in elementary school, and but back then, I mean, by the standards of today, of course, everything was incredibly primitive. But back then, it was really advanced.
Sure.
So it wasn't like we felt like, oh, we're working in the Stone Ages.
Yeah, of course.
We're working on stuff that seemed cool and interesting, and software. Of course, there was uh, proprietary software, but people passed around software a lot. You just
Yeah.
showed people, this is what I'm working on. Um, and then, so, you talk about putting the pillars together. That's interesting. It never really seemed like that. I mean, I wasn't obviously, I was far from the really beginning of computer programming, but, when I was just started working on GCC, which I say was around 1990 or so, and I started contributing to it. And then I joined a company where I did pretty much full time on GCC and the assembler and tools related to that. Um, it felt like it didn't feel at that time like we were creating pillars or anything. It felt like we were creating an alternative to a set of tools that already existed, a set of tools that had been developed around Unix and other systems. I mean, there already were compilers, of course, at that time, 80s, 90s. There were languages. C++ was starting to rise. So what we were doing is providing a free way to use these languages, a free set of tools that you could use to write your own programs. So we thought of it as I say, as an alternative to the existing code, which for no very good reason was being held proprietary within the various companies, Unix companies, and Microsoft too at the time.
Sure. You know, yeah, and when I say pillars, right, like it's tongue in cheek kind of, right? Because nobody
Right.
really knows that history's being made when they're currently doing it, right? There's a
Right.
very you could probably count on your hand the amount of times that you've sat back and you'd be like, "Oh, this is something very, very important right now." I feel like right now, like that's very obvious, like with everything going on in this world with the pandemic and everything. Yeah, there's definitely
Yeah.
history is it, but like when you're working on something and it's just part of your day to day, who knows 20, 30 years from now, like, oh, this is something that has stood the test of time. So that's kind of what I meant by pillars. And it's definitely an interesting thing to think about too, right? Like I'll harken back to when I was in college, and like my professors would always talk about punch cards, right? Because like they would always talk about punch cards because that's the best story that you can tell to people that are just starting out in computers now. It's like, did you know what I had to do? Um, and I would just like thinking about the punch card scenario and just like, oh, you had to wait a day to know if you did something right,
Right.
right? Like that is just so foreign. Um, but so it sounds like you were a little bit after that, right? So you came in when there was no basically assemblers and things like that were built out in a way that you weren't reliant on machines to basically compute your systems for you.
That's right. Yeah. I mean, actually, my mother used punch cards, so I actually have a few punch cards that she had. But yeah, when my first experience was just as the personal computer story was starting. So I had a TRS-80 at
Mm-hmm.
home. That was my parents got me, and so I had my own computer. I didn't have to share with anybody else. And also, so by the time I went to college and so on, everybody was on time sharing systems at that point. We'd sort of moved beyond that whole data center thing where you brought your program and
Yeah.
handed it over, and then they handed back the results.
Yeah. So you mentioned you started out with the TRS-80. So I'd imagine that and correct me if I'm wrong with the TRS-80, they send you the kit, right? Or do they send you just the
No,
completed?
the TRS-80 was sold by Radio Shack. It was a whole
Okay.
computer. You didn't have to put it together yourself. Yeah, it was
Yeah.
kind of a single unit. There was, I mean, it was kind of like a modern day laptop, only much, much bigger,
Sure.
you know.
Did you take it apart and play and try to figure out how it worked?
Not so much. I've always been a software guy. I took it apart in the software sense. It had a ROM. It had a ROM which held BASIC, so you turned it on, and BASIC would just run right out of the ROM. So I disassembled the entire ROM, which took a long time, and figured out how it all works. That's kind of how I first really learned how to program at the low level. Um,
Sure.
I sort of had to. It was. I didn't have a disassembler or anything, so I was just looking at the hex bytes and had a Z80 processor, so I had to understand how the Z80 code worked. And then I, figured out how to write extensions to the basic language, so I could, I could draw circles and things like
Sure.
that. I
Yeah.
wrote games on it. That was the kind of thing I did.
Did your parents probably picked up very quickly that, hey, I think he enjoys this, and so if they thought that enough for you to get you your own kind of home PC, right? Like I think, do you remember any conversation with your parents about, because you mentioned that your mother was in the tech space, right? So was it very much like this is something that you should learn, or you were just always around it and you just kind of grew into it?
I was always really interested in it for some reason, and I no longer remember why. It just felt really cool to me. So it's more like, when I can't remember, seventh grade or something like that. My sister and my parents said, okay, we're going to both of you get a big present for some reason. And I said, I would like a computer, and that's what I got. And my sister got a horse. And
I
actually,
mean,
the horse lived quite a lot longer than the computer did.
well, yes, I would hope so. Especially, I don't know what the lifespan of computers were in that
Not
time,
great.
but like, yeah. Well, now it's like they say 3 years, right? Especially with like a laptop. If your
Yeah,
laptop is 3 years old, it's time to get a new one. Home
yeah.
PCs, not so much because you can replace the hardware on them pretty easily if you need to. Um, or desktop PCs, not home PCs. Excellent. So, and then you mentioned that you went to college and people were kind of on a timeshare deal. So, did you kind of pick out really, really quickly that you wanted to do you want to get into computing right when you went to college, or was it something that maybe you thought about other careers and then you
No,
immediately gravitate towards? Yeah,
I always wanted to be a computer programmer.
yeah,
I majored in computer science at school. I always knew that was what I was going to be focusing on. It was just always very interesting to me, and it still is.
yeah. So I'm curious about your experience in college, right? So you mentioned so it was a little bit after the announcement of the GNU project and those sort of things. Was there like I'd imagine that the community that was around in college, at least when I was in computer science in college, like everybody just hung out in the computer lab, right?
Sure.
Like literally like you were either in class or you were in the lab. Like even if you didn't have any assignments due, you were in the lab because that's where the community was, right? I'd imagine something akin. Like you build really, really strong bonds with people that are kind of sharing the experience as well as the dissatisfaction of writing the same code for the same professors over like a 2 or 3 year period, right?
Hmm. Hmm. Yeah, yeah, yeah.
Awesome. So when you graduated, you said you went to your employer, your first employer. You worked on GCC basically straight through. Um,
I should correct. When I joined that company, which was a little company started by a friend of mine, we GCC. I hadn't been exposed to GCC at that point. It was a little bit
oh, okay.
later that GCC entered the picture, and I just started playing around with it.
Okay. Yeah, so I took a look at your bios, and you were nice enough to list like all of the cool open source things, and it's pretty impressive. Is there one thing that stood out to you that you worked on, and while you were working on, you're like, oh man, this is really really cool. Like a lot of people are gonna get value out of this.
Oh, that's interesting. Um, well,
Or let me change the question just a little bit, right?
okay.
Have any time during when you were building something have you ever thought like, oh, a lot of people are going to take advantage of this, like this is really good, or is it kind of for the love of the game, so to speak, right? Like you're learning something and you're port like for instance like you did work with Postgres, for instance, right? Like you did some porting for Postgres, right? You when you were working on something like that or any of the other things that you've worked on, was the thought when you're doing it like this is going to be really valuable to the community, or was it like I just like figuring out how this stuff works?
it was more the latter.
Yeah.
Um, I mean, I, in terms of value to the community, probably the closest was UUCP, which was a project I started myself. There was
Hmm.
like a already UUCP was this mechanism that computers used to transfer files across phone lines, and a lot of email used to be sent over
Sure.
UUCP email, and then this thing called Usenet News. I don't know how many people are familiar with Usenet these days, but it was sort of a I don't know how to describe it anymore. It was like there were topics, and you could
It's
post
like
on
it's
topics.
like a bulletin board kind of to some
Kind of like a
extent.
bulletin board, but a
Yeah.
little bit different in that it was organized in topics and it was transferred between computers, so you accessed it locally on your local computer, and it was much bigger than any bulletin board system I was ever familiar with. Um, but so at the time, UUCP, there was a proprietary implementation that came out of AT&T, which most people use, but there wasn't a free version of it. So it just seemed to me there should be a free version. And let me walk that back a second. There was a free version of it that John Gilmore wrote, but it wasn't. It had some deficiencies. It didn't have all the features. It didn't handle certain cases, or so it seemed to me at the time, anyhow. So I thought, okay, here's an open space. I'll just write my own free version of UCP. It'll be a cool project to work on. It'll be fun, and hopefully people will get some use out of it. And so,
Yeah.
yeah,
Okay.
so both things. I didn't think it was going to like take over the community because, as was the case in those days, we were writing free alternatives to existing code, or at least I
Yeah.
was.
Yeah.
So, it's not like people didn't have UCP available. Um, but this was a free version that they could use, that they could tweak, that they could customize for their own purposes.
Yeah.
Um, so,
Well, that's kind of that's at least that's what I see is like one of the growing like values of open source, right? Like you can take the open source, you can take the package, or you can take the whatever, and you could use it as is, which is extremely valuable to some people. Or I think where the true value of the open source is, you can figure out how it works, and then you can modify it, especially to your needs, right? And I
right.
think that's why a lot of people, at least when I've talked to, they really like that. It's not like, oh, I'm going to be internet famous, or I'm going to be able to find any job I want because I wrote this package that sits in GitHub. It's more like people will start to understand the reason why I built it and find new ways to extend it that I never thought. Right.
Sure.
One of the things I was in a team meeting a couple of weeks ago, and we were having this conversation about this system that's being built, and it was an executive was on it because we were presenting it to an executive, and they said, "Oh, okay, well that's very interesting. Can you talk more about it?" And it was talked about how we kind of transitioned from one way to the other, and they asked, "Why did you do that?" And their response was, "Well, we saw something in the open source community that was doing something very similar, but it wasn't doing something similar. But the the elaborate way they were implementing it was substantially different than how we did, right? And it wasn't like, oh, we're going to steal their ideas. Their ideas triggered something on our side that
hmm
allowed things to be substantially more efficient. And as any good executive will say, oh, well, why didn't you think of that in the first place? But but it's I see it as like, hey, this is an open source thing that not just we take something in the open source world, we see something that's being sold and we try to make some free version, but then there's an opportunity where companies like Microsoft or companies like Google or companies like Amazon or any company, frankly, can see something in the open source space and say, hey, they're doing something really, really good. Let's try to take advantage of that. And I think that only makes things substantially better, right? For the most part.
Yeah, totally agree. Um, yeah, I mean, computer programming is a place where it really helps to see what other people are doing, to share ideas, to move the whole field forward. Yeah.
So when you were working on GCC stuff, and then eventually you probably switched jobs and things like that, or did you stay in GCC for a very long time? I'm curious to know kind of what your progression was as it pertains to like, oh, I worked on this and then I worked on this, and now I'm one of the language designers for Go.
I worked on GCC for quite a long time. Yeah, after I worked on UCP, I got a job. When I worked on UCP, I took some time off, so I was just hanging out, living off my limited savings. And then I joined a company called Cygnus. At the time, it was called Cygnus Support, later Cygnus Solutions, and they were a free software shop entirely, which was really attractive to me. And their primary job, their main source of income, they had a number of sources of income, but the main source of income was to take GCC and port it to a new microprocessor. This was in the mid 90s when a lot of companies thought, our way to fame is to develop our own personal microprocessor and get it used in all kinds of machines and devices. And in order to do that, of course, we need to have a compiler. And we found that most people out there, this was the time most people out there were starting to use GCC. They're familiar with it. And so we need to have a GCC port for our microprocessor. And also, GCC happens to be free software, so it's the one where we actually can get a port, since we can't get these proprietary compiler companies to port to our obscure microprocessor. So they would come to Cygnus and they would say, please write a port for our microprocessor so people can write C and C++ code. And that's what we did. It was kind of a machine. We could crank out a new port in 6 months, and their microprocessor would work. And of course, nobody remembers most of these microprocessors anymore. Sure. It turned out to not be a great business strategy, but it was a good business to be in for a while. And yeah, then let's see. So then so I worked on GCC there, and really, then I worked for some other companies again, primarily on GCC, and I was hired at Google mainly to work on GCC for that matter.
Okay, so GCC has been very influential in your career path then.
Absolutely.
Yeah. And so when you started working on GCC, did you think that, like, hey, I could definitely work in this field the rest of my career? Work in the space, sorry.
Yeah, I don't think I thought I would work on GCC itself, although I still have, but I certainly thought this is what I like. I like languages, I like compilers, I like tools. That's just the area of programming I'm most attracted to.
Awesome. And then eventually you got to Google, and then we were talking before we went live, and we were talking a little bit about what you're currently working on. So do you want to talk just briefly about I kind of already hinted at it, but what you're currently working on, then we can kind of talk about the history of that.
Yeah, I work on the Go programming language. So it's really, covering the language itself, the standard library, the tools around the language, helping the community. And there's a GCC port of Go, so you can use GCC to compile Go code, and I wrote that. That's how I originally joined the Go team, actually. I heard about the language when I was at Google, and it kind of jibed with a lot of stuff I'd been thinking about in terms of how to write programs. And then, there's a new language, and it just seemed really cool to me. So I said, well, this is not a complicated language. I can write a GCC port for this language. And so I did.
Sure.
And I showed it to the Go team, and they were like, wow, that's odd. But then, pretty soon after, I was able to join the team and just start working from there.
So when they say odd, was it in a good way or a bad way, you think?
A good way. I think they were surprised and interested.
Impressed,
because, it was a very experimental language
sure.
At the time. It was, Go has been remarkably successful. I'm certainly amazed by how successful it's been. But, when we started it, I say we, when they started it, and then later when I joined the team and was part of the team, what we were thinking was these are some good ideas. Let's get these ideas out there. Let's maybe get them into more established languages. Let's just see how it goes. We're just trying this out, and people really picked up on it.
Yeah, we talked about this just very briefly before we got started. It's like there's been some very, very well-known projects that were written in Go, right? Like we talked about Kubernetes, we talked about Docker, and it's very interesting. It's like if, for whatever reason, if Docker was like, oh, let's do C++, or if Kubernetes was like, oh, let's use Java or any other language or what have you, right? Would Go have been something that was as, I guess, noticed, right? Because now, like, I think a lot of, at least from my experience, if you haven't heard of Go, like, not if you're a developer or know how to build in it, but like if you don't know about Go and kind of at some level, like what it provides that other languages don't, like you should, right? I think it's very important to get an understanding of languages in general. You don't need to be an expert, but if in a pinch you could write like Hello World, or write a for loop over some data source or what have you, right? Um, so I think there's value in that. Plus, it just stretches your mind about how different ways of thought, because it's very much, I always found it very interesting that programming languages are called languages because obviously languages have a different connotation. Um, but it's very similar, right? You speak in code, right? Instead of with words. And that's always been kind of interesting to me, but I'm rambling.
No,
Um,
I totally agree with you. I
yeah,
think it's very true. It's really good to learn new languages, new
yeah,
computer languages, and new human languages. But new computer languages, as you say, learn different ways of approaching problems.
yeah. Plus, I don't know, from my experience as somebody who's been trying to learn Spanish for the better part of 15 years, um, it's easier to learn programming languages. But uh, um, so currently with Go, right? Like we talked about this a little bit. Like it's a known solution, right? Very feature rich at this point, but there's always people in the community that are kind of looking for new things and looking for the language to advance, right? So, as you're building out kind of the plan on how you add features to the language, what does that look like?
um, Well, let me first say that actually wouldn't actually describe Go as feature rich. I think it has the features that it needs, but it's a fairly simple language, especially in contrast to a language like C++. It does not
Sure.
have that many features. We've always felt that simplicity was a really key aspect of the language. And again, I say we, but really I should refer back to
The
the
royal
people who
we.
started the language, especially Rob Pike, who's really focused on keeping the language simple and easy to
Yeah.
learn and easy to understand. So when we're looking at new features to the language, that's really one of our main focuses is like keep it simple. We don't need another way of doing something, even if it's more convenient. Um, it's got to be a lot more convenient for it to really be worth adding. At the
Yeah.
moment, we're actually very seriously exploring adding a big feature to Go, which is generics, support for
Sure.
generic programming
Yeah.
in the language, which most other languages have, most modern
Yeah.
languages have. But Go hasn't had. So we've been exploring for some time how to add this feature. And the focus has always been, I think, on how can we get the power we want without complicating language while still keeping it easy to read, still keeping
Yeah.
it easy to learn. And so that's really how we try to keep our focus.
Yeah, and you definitely don't want to be in a position where you add something and then people's response was, "Well, I have to rewrite everything to take
Right.
advantage of this feature," right? Something like
Yeah.
generics, so uh, I started out in .NET, and when .NET first added generics, or C# first added generics, it was very interesting, right? Like it's like, okay, this is great because at the time, like most other languages, had some form of generics, but there's always like this. Well, to take full advantage of this, there's a lot of code that needs to get refactored. Um,
Mm-hmm.
and I will say it's just something, and you're being a bit modest, I think, about kind of the power of Go, because you couldn't write something like Docker or Kubernetes or anything else that's written in Go if it didn't have every feature needed to write those things.
That's fair.
Um, um, but yeah, like I think one thing that you could say about any programming language is there's always things that the community is asking for. Especially like we're in this world right now where people really love the idea of functional programming, right? And
Mm-hmm.
a lot of the major programming languages that are out there, like they're not functional.
Mm-hmm.
So adding functional concepts to it without literally breaking everything is something that's very interesting. Um, so one of the things that I've always been very interested in, and I'd like to get your thoughts, just in general experience about Go. The first thing when I first started learning Go, the first thing that really hit me as like, why is this thing? And maybe you could help teach me why it's so important, right? So if you call a function, the function always returns an error, right? And I always, even if there's no error, and
Well,
my
it doesn't have to return an
it
error. It
yeah,
often does.
but it can, yeah. And I always thought I was like, when I first saw it, I'm like, that doesn't make any sense. Why did anybody ever do that? And then as I looked into it, I thought about it more. I'm like, it's actually quite brilliant because you don't need to worry about if it returns an error or not. And I want to know, like, what are your general thoughts? Because that's something that's very different than a lot of other languages, right? Like, a lot of languages are very expectant on catching and throwing and all that sort of stuff, right? So, yeah, like, you want to talk about that a little bit? Just in general, what your thoughts are from a design perspective?
Sure. Yeah, as you say, a lot of languages use exceptions. to handle errors. And I guess the simplest way to express our point of view is to say that in when you're writing a program, errors are not exceptional.
Yeah.
Errors happen all the time for all kinds of different reasons, um, and you should always be programming, thinking, you know, these are the errors that can occur here, and this is how I'm going to handle those errors. Um, with exceptions, you have this additional hidden flow of control path that runs through your whole program, and you always have to be thinking, um, or rather, you should always be thinking, now I'm going to call this function and it's going to return, but it might also just suddenly throw. And if it throws, it's going to run through my current function. So I have to write my current function such as the where that some kind of exception can pass through it. And I have to make sure that it does any kind of cleanup that's appropriate. Um, and languages with exceptions have all the constructs you need, obviously, to make that happen.
Sure.
But the point is, you always have to be thinking about it. And in Go, I mean, you have to, why force people to, if people are always going to have to be thinking about it, and they are, then in Go, let's make it explicit. Let's put
Sure.
it right there. So they actually have to decide in the moment, not am I going to forget about exceptions, but here's an error. Now I have to do something with it. I can choose to ignore it. That's fine.
Yeah.
But I have to make that choice, and I have to be explicit about that choice. So when I'm writing the code, I have to be thinking about it. When the person's reading the code, it's clear to them what's going to happen. Now, it definitely means that you write more code in Go
Yeah.
because you write more code on how to handle errors. And we've spent a lot of time and effort. The community has put a lot of time and effort into how to make that better and simpler. So far, we haven't found any approach that seems fully satisfactory. And I don't know if we ever will. Um,
Sure.
but I'd say I mean, so that's the thinking about it. And although I say Go doesn't have exceptions, it does have a way to throw an exception. It's just kind of not done in ordinary programming. Go has this
Sure.
panic function, which
Yeah.
causes the program to throw up, and you can recover from a panic. But that's really only used in Go for um, what I would call truly exceptional cases.
Yeah.
So
When system resources are at risk, right? That's
right, that,
that.
that yeah,
Yeah.
that kind of
Like,
thing, or when the program encounters some situation that should be logically impossible.
yeah. Like I always thought it funny. Like I was in again. I'll use an example of when I was in college. Like we were writing something. We were writing a programs in. I can't even remember what the Scheme. I don't know if you're
No,
familiar with
yeah,
Scheme, yeah. And I remember that we wrote some program in Scheme to do I don't know some recursion stuff because that Scheme is great for recursion. Um, and teacher comes or the professor comes in day after our assignments are due, and he's like, "I'm actually very impressed. Only two of you students crashed my system."
yeah.
and my immediate response was that's impressive, but I guess when you think about what recursion can potentially do, right? Like the thought of it just taking away all of your memory or whatever. And but your point about like there are some situations in Go that you need to be very deliberate in. Hey, this program is going to have a very bad time because there's definitely a difference between like, oh, you have some logic issue where it's like, oh, you have like this number is supposed to be greater than 5, but it's 4, right? Like
Mm,
that's technically an error in some cases if you're expecting a number, but it's not like exceptional. I think to your point, right?
right.
Which is quite an interesting way to think about it because at least from my experience, like most of the major other programming languages are very deliberate in like if something isn't ideal for whatever case, you need to handle it in a particular way, which I think is kind of interesting. Um, so when we talk more about some of the other things that Go has, right, and some of the things that you're looking to add, like you mentioned generics, but are there any other things that are, I guess, already adopted as a part of other languages that you'd like to bring in that are, maybe some more like object-oriented things or some other functional things from other functional languages? Like what, are there any things that I'm trying to think of a good example, like in C++ plus plus or something that's like, oh, it'd be great if Go had this, right? Because I see that a lot where, like, even C Sharp, we're taking things from other languages, especially functional languages, because people like writing in functional languages. You see Java doing very similar things, right? Like, does Go look at other languages and say, oh, that would be something that we would love to have in our language if it's not too difficult to implement?
We look at languages, other languages all the time, of course. I wouldn't say, but I wouldn't say that we do it quite the way you're describing. It's sort of the philosophy of Go from the very beginning has been, let's write code in Go and let's see what difficulties we encounter, what kind
Yeah.
of problems we run into, what aspects of our code are hard to write. And so, and at that point, we start to say, okay, here's something that is problematic for us.
Mm-hmm.
It's awkward or inefficient or whatever. That's the point where we go and look at other languages and say,
Yeah.
well, they have the same problem. What do they do? And can we borrow those ideas and bring them into Go? So I wouldn't say it's not quite, it's not like we look at other languages for cool things and bring them into Go. It's
Yeah.
more like we write and Go and we say, here's an issue. And then we say, how can we address this issue? So generics is definitely the biggest one.
Yeah.
And another one which comes to mind, and in no way am I saying that Go is going to do anything in this space, but it would be interesting if we could.
It's going to be on the internet forever, the statement, so be very, very careful.
That's right. It would be interesting to have some kind of support for immutability in Go,
Sure.
where you can say like, not where you can, I mean, on the one hand, say like this variable never changes after some point of initialization. That would be nice. And then on the other hand, it would be nice to have a way to say this function does not change this data structure, and we can guarantee that in some way. It doesn't necessarily have to be in the language or in the compiler. It can also Go has really strong support for analysis tools. So if there was some way that we could analyze the program, if there was some way we could express in the program, I want this statement to be true, I want it to be the case that this function never modifies this object, and then have a tool which proves that,
Mm-hmm.
that would also be an acceptable way to approach the problem. So I don't know what we're going to do in that space, and we may never do anything, but I think it would be nice to have something. And of course, in C and C++, that's done through the const type qualifier.
Yep.
But there's various reasons why that doesn't seem like the right fit for Go.
Sure. And I think also one of the things as well, like you always have community people, right? People in the community that are like, oh, I came here from C++, or I came here from Java, but I missed this feature, right? I imagine
Absolutely.
you get that constantly, right?
All the time.
In the, I don't know how you usually take new feature requests to the language, like people open issues or if people have discussions or what have you.
Yeah, all of
it. Yeah, but I'd imagine it's very like every day you probably come in with somebody asking, "Oh, I want this," or "I want this," because Go is so performant, right? Like one of the big, benefits of using Go, I think everybody kind of knows this at this point, is that it's very performant. It runs very, very well, and it does some very heavy lifting without taking up a bunch of resources. And people love that. But then when they go to Go, they're like, I think maybe to my example earlier, it's like, oh, I really need this one particular thing for whatever reason. Whether it be, immutability, I think that's a really good example, right? People are like, I really want to have that const keyword.
Right.
And so how do you deal with, obviously since it's in the open and the community is a huge benefactor and contributor to the language itself, like how do you bring in the community to help, whether it be working on new design features, whether you have like open meetings where people from the community can come in and listen in, like how do you kind of bring the community into the I guess the language schematics process?
Sure. Yeah, we have this proposal process. It's not terribly formal, but we have a process saying this is what you should do if you want to have a change to the language or to the standard library or to the supporting tools or whatever. You file an issue, you lay out the proposal, you lay out the background, the reasoning, exactly what you want to change, and then we kind of split it up into language change issues and everything else issues
Sure.
for the library and the tooling, and then there's a review process that we go through, and the review process is not currently open to the public, but we try to drive to consensus. We try to make sure that
Yeah.
all the right people are being brought in. We try to say we try to point out the issues that need to be addressed, and we try to have sort of a community consensus. In the ideal, a community consensus toward here's the way this change should look. Here's how it should come about. And then if we can't get that consensus, we just say, well, let's just set this aside. Let's put it on hold. Um, let's see if we can get it to a good state. Or, of course, I mean, sorry, I should say, often we just reject it outright. I mean, it becomes
Sure.
clear that
Yeah,
it's
yeah,
just not going to be, half the community is opposed to it. It's just not going to happen.
yeah, yeah,
So, uh, and we're also very, very serious about backward compatibility in Go.
yeah.
We want to make sure that as much as we possibly can, old Go programs should continue to work with the modern Go language. So that can be just a showstopper. And as you say, a lot of people do come in from other languages and they think, I would like this feature. Go's been around long enough now that we can often point like, yeah, we talked about this like 4 years ago. Someone
Yeah,
made the same suggestion. Here's all the arguments that were made back then. Take a look at that. And if you have
yeah,
something new to say, we'd love to hear it.
sure.
But if you don't have if it's just the same ideas as before, we already thought about it and sorry.
Yeah, no, of course. I think there's value that, like, I think a lot of people these days, they're very worried about upsetting others, right? And if somebody, like, they put the work into, like, oh, I'm gonna like put together this specification, and I'm gonna say, oh, I would love to see this, and they put together a feature proposal, and the response is, we've talked about this 4 years ago. Like, some people will be like, well, what? I put all this work into it, but it's like, well, you didn't put enough work into it because you didn't look to see if we've done it already, right? Um, but I think that's so. I've talked about this a lot too, where there's good things and there's bad things to community, right? To open source. And I think one of the great things, obviously, is the fact that you build a community of things. But on the same token, you kind of build echo chambers, right?
Mm-hmm.
Where like you have people that are very diehard to a particular thing, right? Like if say for instance you have people that are in the C++ space and they're very diehard about C++, but for whatever reason, maybe they're adopting Kubernetes at their company, or other containerization tools or anything else that Go would be a great candidate to build a solution in. So they have to learn Go. So they start going through stuff, and then they're like, well, this is terrible in compared to C++. I hate this. But I need to work in the constructs of it, so let me try to be a part of it. But they come in from a negative angle. Like, have you seen that? A lot of people just coming in and quote unquote bashing Go because it's not like other languages. Or for the most part, a lot of the community people that come in, like they're very passionate about the language and they only want to see the language do better.
We see both. Yeah, people do. I wouldn't say I wouldn't say we see a lot of people coming in to bash the language. It definitely happens from time to time. We just try to be polite and say,
Yeah.
we've never tried to claim that Go is the answer to everything. I mean, quite the
No.
opposite. As I say, originally Go was an experiment. It was an
Yep.
alternative that we hoped would get people to think about these ideas. So someone comes in and is like, Go sucks compared to C++. And they're like, yeah, hey, use C++. It's
I
okay.
mean, yeah, I like it. I think that's a fair response. I think one of the things too is that people see the potential of Go, but they don't quite understand. Like you mentioned a couple of things. You want it to be very performant. You want it to be very simple. You want a lot of things that if you just start adding a bunch of stuff, like it's going to get bloated. The libraries are going to get too big. They're probably not going to be written in ways that are the most performant because you have to talk about backwards compatibility. So you end up in this, and I apologize, you're going to end up bastardizing the language, right?
Right.
Like, and that I think that's is as a language designer, that's the last thing that you want, right?
Yeah.
I think about C++, especially for instance, right? Like C++ has done a very, very good job of adding basically every modern feature into it, but it's taken 30 years, right? So it's crazy to think, and like there's some people that I know who work at Microsoft that are very they're on the C boards and things like that,
Mhm.
and it's whenever I've had a conversation, it's very challenging. Like you have to always assume that somebody's going to come in with a language that hasn't been touched in 25 years, and you can't break them,
Right.
right?
Yep. Yep.
And especially when you're talking about writing very large systems like Docker or Kubernetes or anything that can extend those, like the last thing you want is to break something and then this huge system goes down because you tried to add something to the language that broke backwards compatibility, right? Obviously, you would never be in that situation because it's your job as a language designer to think about that. But it's just there's potential for the worst possible case. when you're adding things, right? I think that was
Yeah,
not just languages, but with anything, right? Like even if you're building a system and you add a feature, you're probably going to break a bunch of stuff.
yeah, it can happen. It's definitely hard, and people use your code in unexpected ways.
Sure.
At Google, we like to talk about what we call Hiram's law, named after a guy who works at Google, but the terminology has escaped the company now. Hiram's law is basically that any any way that your system works, documented or not, is still a feature that you have to preserve in that system.
Sure. Oh,
And of
that's
course,
interesting.
Microsoft is extremely aware of it. Microsoft having made sure that all these ancient Windows programs still continue to work, even if
Yeah.
they were relying on bugs in the old
Yeah.
system.
Yeah. Which I always found kind of funny, right? So I used to work as a consultant, and I had a customer that was very using the Windows APIs very, very heavily, like the low-level Windows APIs, and they were having an issue. So we go in there and we're looking at stuff, and we're like, well, what have you done? Oh, we all we've done is we've like upgraded we installed some security patch, right? And
Mm-hmm.
what ended up happening is like, uh, basically a catch was added to some code to help out with an API issue that this program that this customer built was dependent on it throwing an exception, and it just completely broke their tool, right? And they had no idea why. It's like, oh, we just added a patch, like, but it's
Right.
crazy to think about that, right? Where, and like the customer is a very well-known company, and the tool is a very well-known tool, and it literally was dependent on the Windows API bombing in a particular case, which is hilarious but also terrifying.
Yeah.
Um, so one of the things that I'd like to finish up on, because we're about out of time, is so with Go especially, right? Like you talked about adding new features to the language in potentially in the future and things like that. But where do you see the future of Go, right? Like you talked about it, it's not a very old language in the larger sense, but it's been around for 15 years or so internally and now externally, obviously. But where do you see the language going? Yeah, it's right now. It's I think a lot of people think about it as one of the top tier languages, right? You know,
Good.
they say, yeah, well, I would hope so, right? It's like they say C++ and Java and C Sharp and Go and Rust, and they just name like a handful of like 5 or 6 languages that companies build software on. And so, with knowing that, like, what do you think the future of Go is? Is it going to continue to get more adoption? Are you thinking that there's going to be always this niche area that Go fits in very, very well, but branching out into other areas probably not the best case? Like, what are your thoughts?
I think it's
Other,
going to. I'd like to believe that it's going to continue to gain in adoption. Yeah. I think it's a pretty general purpose language. I don't think it has any particular niche. I don't think it's ever going to be playing in the areas where performance is absolutely essential and critical. I don't think that's Go's strength. And I don't think it's going to be playing in the deeply embedded system space that much. And I
sure,
don't think it's going to be used for kernel programming, but I think it's going to be used for general purpose programming. I think it's perfectly useful for network servers, for databases, for containerization, obviously, for like system services. It's also good for scripting and tooling. So yeah, I think it's still got a pretty good future. Um, I don't know if I'm sure we'll continue to tweak the language a little bit. I don't really, at this point, anything could change, but I don't really see any big changes coming to the
sure.
language. I think it's more going to be making the libraries more powerful, making them easier to use, and obviously adapting to whatever new technologies are coming down the pike. Um, but I'm optimistic.
Yeah, I think, well, at least from my experience, I think that Go is something that I think I mentioned this earlier. Like people should at least look at for their solutions, right? I think, um, maybe to your point, like maybe Go doesn't need to rule the world, but I think Go has a very, very valuable place, and I think that space is pretty big, right? I think there's going to be definitely a point in time where people will probably choose Go over more traditional solutions because of simplicity, right? Like I think
Mm-hmm.
like one of the things that I've seen, like I have a friend who works at a company here. I live in Seattle, company in the Seattle area, and all of their backends are C++, right? And they've started to look. It's like, well, Go, like, we're not doing anything absurd in C++. We don't need like all the features of the language.
Right.
Like, do we really need C++? And they're looking at Go for a couple of their smaller systems as proof of concepts. But I think that's something, right, where if you want to go down this path of, if I can look like to your point, if I can read the code and it makes sense, and if I can write the code in a very quick way and not have to worry about all sorts of absurd things, like, it's a great option. And then there's some other situations, like maybe I don't want to write a whole bunch of boilerplate code. To your point about, you're going to write a lot of code with Go. That's just part of the game. If you don't want to do that for whatever reason, like, it might not be the best fit.
Yeah. And yeah, I mean, alluding to what you said, I mean, one thing I've noticed about C++ over the years is that C++, it's a great language and I still like it a lot, but people programming in C++, people writing complex programs in C++ can often get into this kind of complex discussion about how to use the language in the most effective way.
Yeah.
And that's totally understandable. And it does help with the fact that C++ really is an excellent language for highly performing code. But that kind of discussion, it's like, what is the best way to express this problem in the language, and how's the best way to use these language features? That's a discussion that happens in C++. That's not the kind of discussion we want to see happening in Go. That's not where Go wants to be. In Go, it should be like, okay, it's pretty clear I'm going to express that in Go. We want people working in Go to be thinking about the problem they're trying to solve and not about the tool they're using to solve it.
Yeah. Yeah, no, I think that's a good point. You want the tool to get out of the way. Like, I think if you're building a solution, I think the last thing that you really want to do is try to do this juggling of implementation, right? The implementation be pretty straightforward, to your point. Cool. Well, again, Ian, I want to thank you so much for coming on and chatting with us. Yeah, I always ask our guests, at the end, if you can explain or describe open source in one word, what would that word be to you?
In one word.
Yes. You can cheat and use 2 or 3 words. It's fine.
Generosity.
That's great. That's awesome. It's very important. The standing on the shoulders of giants that I alluded to earlier. I think that's, generosity plays very well in that. So, again, Ian, thank you so much for your time today.
Yeah,
And
thanks for
thank you,
having me.
everybody,
It's
for
been fun.
tuning in to Coffee and Open Source. And enjoy the rest of your day, everybody.
Thanks very much.